Record. Okay, we're recording. Chapter 10.6, Intermediate Algebra, Monday, October 5th. Okay. So since now we learned all about the radicals, now we're going to solve equations in which the radical is in which the x is in the radical. All right. They're called radical equations because the variable is under a radical. The name of the equation comes from what has been done to the variable. The variable is the object. If it was x squared, it's quadratic equation. If it's this, it's a radical equation. Right. Okay. So here is some example of radical equations. You see, it doesn't matter. It could be like to the power, fourth root or square root. As long as you have variable in the radical, it's a radical equation. The principle of powers is saying we can put both sides to a power. If you have a equals b, then if you put this to the power of 2, then b should be to the power of 2, right? It's going to be still true. Easy peasy. Solve. Okay. So here is one. It says solve. Wow, this is big. So here is your equation. Right here. Okay. So solve it. So what you need to do, your goal is to isolate the radical. So let's isolate the radical on one side. Here you go. Minus the 3, so this is 6, right? So now, how can you remove the square root? Square both sides. Yeah, you're going to do the opposite because radical is technically 1/2. The radical 2 is 1/2 exponent. If you square both sides, you're going to get rid of the radical. Right, Mariana? So if you do this, then it's going to come out just m equals 36. However, I usually don't make you check your answer, but in this chapter, you have to check your answer because sometimes you get something which is called extraneous solution. Extraneous solutions, means which are not really actual solutions. They pretend to be, but they're not. So you have to check your answer. So here is easy. 36, I go back, put here 36. 6 plus 3 is 9. So this checks. But you see, sometimes it doesn't. So we have to check. Okay, this one, blah, blah, blah. Check. Works. Okay. Caution. Oh, here, this is what I said. Does not always give equivalent equation. A check is a must. This sounds like a movie title almost. When are they going to open the movie theaters? No.
I don't think anytime soon.
Okay. So we're going to do this example, and I don't want to, I'm going to hide, let me put it right here. It's kind of gigantic. Well, actually, I'll use it right here. Here is the problem, and I'll hide it, and then we'll solve it ourselves. This is such a shame. Where are the new movies which are released? I don't even, I don't know about it. I don't know.
Just go on Google and type in the movie that you want to see.
But I don't know which movie. I don't know what's offered. They're not.
It's like a new movie, 2020.
I guess. But then.
I really want to see this one that's supposed to come out on the 17th. It's called Two Hearts or something like that. It's a chick flick. I'm a chick flick.
Oh, okay. So how do you know? Well, it's okay. You can be a chick flick.
I saw some commercials about it on Netflix.
Oh, Netflix. No, Netflix is not.
I think it was YouTube. I don't know.
Maybe somewhere. And this is the thing. This is the way I see the movies on YouTube. If I watch something, if I watch Christian song, and they advertise Christian movies. Okay, so we want to. So here is the equation. You see, you have two variables though. So you want to isolate the radical. This is not just the variable. Isolate the radical is the goal. Radical. This is the radical. I'm just isolate the radical. So how I'm going to isolate it? I need to move the 1. You see this 1 next to it? Let me write it with yellow. So here, I have x equals, I don't know why I'm rewriting it. I don't want to rewrite it. I'm going to minus the 1, see?
Can you just add it to the 5?
No, look at this important part right here, see? The radical finishes right here.
Okay,
That's why I don't like when they put it on the other side, you know. If it was me, I would write 1 plus radical x plus 5. Because you can be confusing, you need to pay attention, okay? So it is, this was a good question, okay. So minus the 1, so I have x minus 1 equals this. So now what do we need to do to get rid of this radical with the second step? Okay, square both sides. So now we could have problems. If you don't know how to square this left side. Do you know the formula, which I never taught you?
Do we know the formula you didn't tell us?
Because it's not very useful when you factor. No. Okay, now just let's, what you can do is just FOIL it by itself, but don't forget, you need to FOIL it by itself. This is not x squared minus 1 squared. No, you need to multiply it by itself. And the other side is just x plus 5, right? Because the square root cancel. So what happened is x squared, I'll just do it the long way, minus x plus 1, all right? And distributed. So then you got x squared minus 2x plus 1 equals x plus 5. So before we continue, here is the formula, which I never told you. Okay, so here, if you look at this, oh, no, not this. So if you look at the top, let's make it blue in this. If you look at this, see this, just with the square, okay? This is always equals the first thing square minus 2 times the first thing the second plus the last thing square. Hold on, I missed my one here. Wow. Here is the formula which I never taught you right here. Special, okay. You have a plus or minus b squared equals a squared plus or minus 2 times ab plus b squared. The b squared is always plus at the end. Here is the formula. This is trinomial square is the name. You know, you can just follow them, but it always comes out like this. You have the first thing square plus or minus 2 times the first thing times the second thing plus the last thing square. But again, you don't have to learn it, just FOIL.
Is that a plus b squared?
Yeah, it's always plus at the end, always plus.
Whoa.
Okay. So after this is done, we'll continue with our problem here. Let's make it green. Hold on, Mariana needs to highlight the formula. Okay. So now we are right here, right? Okay, so what we need to do, this quadratic equation. So we need to move everything on one side, make it equal to 0. So it's going to be x squared minus 2x plus 1 minus x minus 5 equals 0, right? I moved everything to the left by doing minus x and minus 5. Now let's combine like terms, x squared minus 3x minus 4 equals 0. I hope it's correct. Bless you. Right? Okay. So now, can we factor it? Oh, yes. Look. The easy way is to factor it instead of using quadratic formulas. So what's going to be? It's going to be x, what numbers? Minus 4 and plus 1, right? Because 1 times minus 4 is minus 4, and minus 4 plus 1 is minus 3. So the solutions are the ones we think they are. From here would be x minus 4 equals 0, or x equals 4, and the other one is, let's put it like in blue, x plus 1 equals 0, or x equals minus 1. So these are my potential solutions. 4 and minus 1. I want, however, to check if they really are a solution. So we're taking those numbers and we're going to go in the first one. Okay, check. So let's write. I'm checking. Let's write with some kind of what cover this. We haven't tried this. So check. So we're going to check right now. Okay, so the equation is, I guess I'll rewrite it again. So x minus 1. Wait, it was always on top. Hold on. I'll rewrite it. Okay, it was x equals square root of x plus 5 plus 1, right? So let's check. Let's put 4. I'm putting 4 first. So let's make it pink. So 4. This 4 equals square root of 4 plus 5. The whole thing plus 1. So this is 9. So it's 3 plus 1. So check. Right. So 4 is a 4 is a solution. Right, Mariana? What I did, I took the 4 and I plugged it in back in the original. Right here. Okay. So now let's check the next number, which is minus 1. Right, checking for minus 1. X equals minus 1. So let's see. Minus 1 equals square root of minus 1 plus 5 plus. Where is it 3? Because 4 and 5 is 9. So square root of 9. Okay. Yeah, it's 3 and I kind of moved it. Yeah. I think I overdid it a little bit too fast. Looks good. Okay. So let's see. This minus 1 equal, this is 4 now, right? So it's going to be square root of 4 plus 1. So square root of 4 is 2. So 2 plus 1 is not equal, right? You see, this was one of those extraneous solutions, which was not a solution.
What do you do there?
I think you just ignore this. So, you know, because the problem is asking you what are the solutions. So the only solution you're going to enter is x equals 4. You're not going to enter the other one, I know. This is what Alex is going to ask you to do. So again, Mariana, you have to check. In this chapter, for those equations, you have to check. Okay. I'm done. I'm erasing all this. Okay, here, blah, blah. What is that? Oh, yeah, the same thing. Moving on to the next page. Check, check. False. You see, the first one was true, the other one was false because it didn't check. They're repeating what we did. So the good news is I did not put on Alex the one with power of 3. But we can do this just so you can understand better the like. You can understand better the idea of what we're doing. Yeah, let me see what it is. Okay, let's just look. Okay, so this is a cube root. You see the cube root? So if you follow the motions, go through the motions, right? We have to isolate the radical. So we isolated the radical here by moving the 2 to the other side, right? Because this finishes right here. So plus 2. So when you do this, you get right here. This is where we are, right? And the pink square. So now the radical is isolated. Now we need to remove the radical. So we do the opposite of taking a radical. We put it to the power of 3 both sides. And oh, look at this. I can just move the thing. So now we got 3x plus 4 is 8, blah, blah, blah. You get x is 4 over 3. So in this case, you don't need to check because the power was odd, right? The problem comes with the extraneous solution is if your power is even. So for example, let's see. If you have let me get this number. If you have 3 squared, it's in your book. Let's make red. Which one did they got? If you have 3 squared, this would equal minus 3 squared, right? This is the question. But in fact, 3 does not equal minus 3, right? So when you square it, you lose this minus, which could be there, but it's not. So if it's odd power, it doesn't matter. The solutions are always solutions, but when they're even, 2, 4, 6, you might have an extraneous solution. Blah, blah, blah. So these are the general steps. Isolate the radical, use the principle of powers mean, put it to the power of whatever it is, the radical. If a radical remains, perform step 1 and 2 again. Sounds almost like a game or something. Check the possible solutions. Okay, so now we're going to, this is the time where we're taking a short break, and we're going to Alex and see if I gave you the long ones or not. We're going to Alex. Where is Alex? He's hiding somewhere right here. Because there was, I think, 1 year the students are so desperate that I just removed it.
So this class is kind of hard then.
Well, I don't know. Let's see if it was. I don't know, because I might have saved the other class. Let's see. So we're going to look at the objectives and see if I put it there. Oh, it's here. I hope I did, because you deserve it. It's good stuff. It's a lot of work. Okay. Chapter 10. Ooh, 70 topics. But we had more time. All right, for this one.
Yeah.
What is that? It's chapter. What is that? It's chapter. Where are the radical?
10.
10, but it's not 10. Oh, here it is 10. Okay. Square root. Okay, hold on. Where are the solutions? Oh, 10 point. Oh, look how nice when we have the book 10.6. Okay. Solving radical with quadratic expression of the radical. That simple as quadratic and word problems. Odd root. I think we have them all. Let me radical simple. I think the only ones which are not here is in the odd property. I didn't do the odd property. There are here, so I'm teaching you. Oh yes. Okay, they're here. Good. This is the hard class. It's going to be fun. Here. Okay. Oh, let's have I used to have fun breaks or something. We never do this anymore. We're so busy recording. Remember, I used to have a fun moment or something. Never had a fun moment with you.
No.
So serious. Okay, how was your weekend then?
It was busy.
Oh, why? You work?
I'm always busy.
Oh. How about you, Kason? But this doesn't tell me anything. She said it was busy. Mine, I don't know what happened to it. It's mine.
Yeah, same.
Oh yeah. I think the weekend before that was nice, but this one, I don't know what happened. But it was gone.
Yeah, with 7 classes, there is no weekend.
No, yeah. It's okay. We'll overcome by the blood of the lamb and the word of our testimony. Okay, so now we have 2 radicals. So I'm going to write it because you need a lot of space.
Oh, man.
Let me see if I have it here so I can write the whole thing. Is it the same problem? Where is it? This is not the same problem. Okay, did you write it down? Oh, did you write it down? So you can tell me what it is. Hold on, I'll hide it. You can probably jump to a whiteboard, but it's okay. I like the black. Okay. So Mariana, what was the problem?
It is the square root of x plus 3.
Okay.
Minus square root of x minus 2.
Okay.
Equals 1.
1. Okay, so here, now we have 2 radicals. So when you have 2 radicals, there are extra steps, 2 major steps. So the first step is pick one radical and isolate it. Usually the one which looks more complicated, but they look the same. So I'm picking, I'll keep the first one and I move the other one on the other side. Because you need to have one radical on one side in order to do, you know, square root property or, okay. So 1 plus radical x minus 2, you're just moving it to the other side. You're adding this to both sides, right? Okay. Okay. So this is, now we're going to square both sides. So let's make it pink, square both sides. Now here the pain starts for sum. Okay. So on the left, the radical falls, right? Okay. So just have the simple x plus 3. On the right, however, we have to FOIL this by itself, and I'm going to write it. FOIL it. I'll do the steps. Hina would like that. She always likes steps. Yeah. So now let's distribute. Yeah. So this is x plus 3. So we're going to do this together, and the next one you're doing it on your own. So 1 times 1 is 1 plus another plus. Well, just for the steps. Okay. I had to square the last one because it was plus by itself. And I was looking at Hawaii. No, I was just looking the weather, and there is a video. My weather always shows me videos. In Hawaii, some people are on the beach, you know, just, we are going to look at it. Okay, we look at it for another fun moment. Okay, let's finish this. Okay, so x plus 3, okay, equals 1. So, you know, those two are the same apples. So just add them. Plus 2 times square root of x minus 2. And then what happens to the last term case? Okay, so what it is, you see square root? Maria? And you're squaring, so the square root falls out. It's just x plus 2 minus 2. Right, you see the last one? This cancels this, or this cancels that, whatever. So this is what we have. So now let's add like terms on one side. So the 1 and the minus 2 would add up. Here, this 1, this minus 2. So you're adding like terms. Okay, add like terms. This is an R. Okay, so we are going to do, I don't know what happened, but 2x minus 2, and then I have plus x and minus 1. You know, the 1 and minus 2 became minus 1. I just rewrote whatever it was. I just rewrote it, but I got this 1 underlined with red. It's right here, right there. I took this dude and I added it to this 2 minus 2. So here we are. So now, next step. Now we're done. So this was Roman numeral 1. Step 1. You know how we have major steps, minor steps. So here is the Roman numeral 2 step, which is the same as Roman numeral 1 step, which is isolate the radical. So repeat. So now this is the new, our new victim is right here. This is the new thing. The blue thing is what we are doing now. We forgot everything we did so far. This is what we are at, where we are at. So isolate this radical. So how are we going to isolate it? I would suggest we just leave it on the right, where it is, and move everything onto the left. Okay, let's, yeah, so it's going to be x plus 3. I'm going to minus this x here, just for Hannah, make her extra steps because she likes them. Minus x, if she ever watches the video, okay, equals 2. Okay. So let's combine. Oh, this is beautiful. The x canceled. Oh, Jesus was merciful in this one. The yellow eggs. Oh, hold on. See? X minus X. They canceled. Otherwise, it would be longer. Too bad they canceled. I didn't want them to cancel now, but okay, they canceled. Okay, make your life easier. So go back and continue. Oh, with yellow. So this would be 3 plus 1 is 4, right? 4. So 4 equals 2 square root of x minus 2. Now, you know, we could, if you divide by 2 would make it easy. So I'm divide by 2. So it's 2 equals square root of x minus 2. Now we're at the final step. Okay, so do this. Square both sides, right? And 4. Let's do this. So 4 would equal x minus 2, right? And then plus the 2, so 6 equals x. Let's see if this is a real solution. Don't know how they can be extraneous. Okay, 6. At least we have only 1 to check. Okay. So we're going back right at the beginning, right here. Oh, make it pink. I want to make it yellow. Let's make it yellow. I'm going right here to check. It is check. 6. I'm going to plug in 6 there. Let's do this white. So square root of check. Okay, check. Hey, check this. I can write a personal check, or you can check. Which one you're going to do? So put 6 for x. So 6 plus 3 minus 6 minus 2. Does this equal 1 is the question. That's a question mark. 9. So this is 6 plus 3 is 9. Square root of 9, 3. Minus 6 minus 2 is what? Square root of 4? No. Yeah, 2. So 3 minus 2, does it equal 1? Yes, it equals 1. Yes, so this check. So this is the solution. All right. This is actually this version, because if the x didn't cancel, was going to be long. Let's just. Yeah, now we do the hard one. Let's just do. Look at Hawaii and the shark. For a second. I don't know if I get the setting. I just got it when I was doing my weather. Is it still there? Let's see what the title was. What I was doing, weather. Okay, this is the weather. Oh, I don't even know. No, oh yeah, it's a what? Shark incredibly close. Okay, shark incredibly close. I need to click on it too. No, Tom Hanks, incredibly close to swimmers in Hawaii. Hopefully we get the right one. Oh, let's see if we get it. Oh, I want videos right here. No. Who's it by? I don't know. It's Kenwick weather. What about shark? Oh, November. No, it will just happen. Shark. Oh, let me see who did this. 1 second. Do you know how to use the phone to look over there, to show the phone there?
I'm not gonna do it there, but maybe just
Hold on, I'm trying to see. Oh, this is the advertisement. Actually, let me copy this and go on YouTube itself. Maybe this would be. We'll go there. Oh, where's my YouTube? Oh. Let's go here and see if we can find it here. Did he? Oh, don't tell me. Oh, I didn't copy it. Oh. It's Kaimana Beach. Okay, hold on. Shark incredibly close to swimmers. Kaimana Beach? Kaimani Beach? Maybe it was Kaimani. Let's see. Well, I think it looks like. Oh, 2 years ago. I think this was just recent. Well, let's see what this chart is. I don't see any swimmer.
Switch to Consumer Cellular and enjoy exceptional value like talk, text, and data for only $20 a month.
Let's see this. Nobody's in the water though. Tiger Shark. It was roaming. Oh, here. Okay. Let's see. I think it's not this one, but.
Is it this one?
Oh, look. Yeah, but look what. I don't see anybody in the water though. Let me see. Oh, look, there is a guy next to it. Yeah, I'm in the weather. Isn't the guy afraid? He's looking at the drone. He thinks it's a dude. This is a tiger shark. This is one of the most dangerous. I don't think he was afraid. Oh, look at the other swimmers. They don't even notice it. It's a see the helicopter makes waves, I think, no?
That's crazy.
Nobody's doing anything.
Nobody's there.
There were 2 people in the water with it. So I need to go to the weather, but this is the one. Here.
That's the one?
I think so. I don't know. What is it? Do you need to go to the weather?
You know when you said you wanted videos?
Yeah, on the weather.
I think you didn't have to put videos.
Oh.
It was on there.
Whatever. We got the idea. There was a shark. It's swimming. Oh, look, a little baby after it. Is it another shark? Let's see the other. Shark attack. Leave swimmers with serious. Oh, I don't want this. Record breaking largest great shark. Oh, no, I don't want this. Swimming with sharks. I don't want this. Woman survive shark. Ay. Shark spotted close to swimmers in Daytona Beach. Oh.
So we see them all the time.
Captain Tammy Melfers with Volusia County Beach Safety says lifeguards and officers who regularly do drill swims are often in the ocean with predators like this one, spotted by Chopper 2, a 4 to 5 foot black-tip shark. Typically, on the Central Florida coast, the ocean is rolling and acts as camouflage for marine life like sharks. But conditions right now are a little different.
And they're always there, but we have had clearer water, and it has been flat surf, so you can see in the water a little bit better.
But it's nothing that, as biologists, we find alarming.
We spoke with Gavin Naylor through FaceTime. He's director of the University of Florida Shark Research Program, and he says he's seen larger shark than this one in shallow ocean water.
They will not target people deliberately. They occasionally bite people, but it's usually an accident because they're chasing schooling fishes.
In the case of this particular shark, and there were actually reports of 2 out there, the animal moved close to swimmers but then just as quickly moved away. In places like the jetty at New Smyrna Beach, famous for, among other things, high numbers of shark bites, the toothy predators can't as easily get away from humans. The inlet is a draw for both sharks and surfers.
The structure of the tides and the way the currents move around is obviously good for schooling fishes, which brings in the sharks. And the structure of the inlet's also really good for surfing.
A surfer suffered a minor puncture wound at the inlet Sunday, though he did not see the shark.
Okay, well, I guess.
Oh my.
Near swimmers, Miami, this in Florida. But this is the same guy when they shot for Hawaii, see? So they don't know what they're talking about. Okay, anyways, we got it. I don't know. I was thinking there are no sharks in Hawaii on the beach, but I guess there are. Okay, let's do another problem. Hey, where is the PowerPoint? Right here. Okay, we need to find one which is not so easy. Hold on. Is this the one not so easy? Oh yeah, this is the one. Okay, let's do this one. So here. Okay, I'm going to save it right here. Give us a black space. Okay. To be the last one, unless you really want to practice one more. So this is the idea. Okay, here is the problem. Oh, look, the radical is already isolated. It's on one side. Sometimes they're on both sides, so we need to move one. We need to isolate one of the radicals. So now we have one. So step one. you know, capital, I mean, Roman numeral 1, or in Spanish, I mean, it's not the, I mean, uno, but I don't know what to say. Okay, so continue. Oh, let's make it white. So I'm going to just square both sides, since, right, square, not this negative, see this negative there, square. So actually, I don't like it how the negative is in front. I'll switch those because it's easy to mess it up. See this one? I'm just switching it for my own, like, preference. It's not that I have to. But you see this minus, I don't like it how it's sitting there. I would rather be on the second one, right? So I'll just rewrite this the way I like it. So it's going to be, so this will be square root of x minus 2.
But wouldn't it just be x minus 2? Because the square.
Yeah, but I'm just going to write it first and then, okay. And then it's going to be square root of 2x plus 3, but very good observation. Minus 2, right? Here you go. I mean, it's nice that it's in front, it doesn't go under the radical, but okay, so now we square them. Looks like a spider. Square. So now, as we said, as Mariana said, we're going to use a lot of space, so I'm trying to be like, okay, a little squeezed, equals. So square, okay, I'm just doing the FOIL thing. Okay, let's just FOIL it for your sake right here. Minus, I'm foiling it right there. See? So it's going to be x plus 3. I'll just do the steps so I leave it squared and squared. Because this time the next. So minus 2 times square root of 2x plus 3. Then minus 2 times square root of 2x plus 3 plus 4. This is all which comes out after you FOIL it. I'll give you some time to think about it. All right, you just multiply by each other. I have too much going on, don't want to. Here you multiply this by this, and then this by that, and then this by this, and this by this. Okay. So you get this. So let's now like simplify it as much as we can. Yeah, let's make it yellow again. So x minus 2 stays. So the first one, because it's square of a radical, the radical 4, so it's just 2x plus 3, right? Then, see those two? They're the same type of mushrooms. You can collect them. So minus 2 minus 2 is minus 4. Okay. And then we're left with 4 plus 4. Oh, look how nice. Okay. Now we're going to add like terms, right? And I'm just going to scratch from here, and I'm putting it here as a 7. I just added them. All right, 3 and 7. So now our goal is to isolate the radical again. So this time, because this one is a negative, not that we cannot multiply later by a negative, but I would rather move this whole thing on the other side. All right, make it positive. See, it's negative. So I'm going to move the radical on this side, so plus this whole thing. Right. Both sides. And let's just plus it now, then later we move the other one. What color? Blue. So it's going to be x minus 2, we move the x minus 2, plus 4. I mean, you can move it now, but I didn't want to. So x plus 7. So now move this x and 2, minus 2. So you're going to do minus x plus 2. And we isolated the radical. So it's going to be 4 equals 2x plus 7 minus x plus 2. Oops, right. So now we can combine the like terms. Marianne, if you have questions, you can ask. This equals 2x minus x, x. 7 and 2, 9. Okay. This is part 1. This is step 1. Okay, looking at this step, you see the 4. If I divide by 4, nothing could happen other than making this a fraction. I don't want it to be a fraction. Or do I? No, I don't want it because you don't want to be a fraction. So now, next step. Now we do orange. Step 2. We have the isolated radical. So the 4, if it's a constant, it doesn't bother. Isolate. So now I'm going to do step 2, which is square root both sides again. This time the x doesn't cancel. Okay, now, so because you have 4 times this, you need to square the 4. So it's going to be 16. And then 2x plus 3. Hold on, let me write the steps and then I will write the steps. So it's going to be 4 squared times square root of 2x plus 3 squared. I'm just writing the next step. See, read this? I just squared the first thing, but square the number and the radical. Yeah, you see what I did? So because I want to save spot, I'm erasing all this. I'm going back and writing 16. So this is going to be 60. The radical falls out. I have 2x plus 3 left. See, 16 times 2x plus 3. Hope you understand where it's coming from. On the other side, we have to FOIL it. So here, x plus 9, I just wrote it next to it on top, right? So now, FOIL it. So it's going to be x squared plus 9x, which is 18x plus 81. Whoa. We slow down a little bit. So then, we're going to distribute this little number here, 16, right? So we're going to get 32x. Does it show the bottom? Oh, almost 32x plus 16 times 3 is 48, right? Equals x squared plus 18x plus 81. We're here. In the previous example, the x squared canceled, so it was easy to solve. Now, the x is canceled. Now, x didn't cancel, so we had to FOIL this whole second part right here. All right, this is the difference with before. Before, there was no x, so we just square. But now, so now we have this yellow thing. So look at the yellow. I know it's a lot. Let's circle between white. So this is a quadratic equation. Why? Because the x squared is the highest exponent, right? You see? So how do we solve quadratic equations? Yeah, factor them, but to do this, you need to move them on one side and leave 0 on the other side. To set them equal to 0, right, Mariana? Okay. Wake up, wake up. So now we'll go right here. This looks like a shark. Oh, like a shark. Oh, it looks so much like a shark. And then the tail. Yeah. Let's use some different color like orange again. So I'm moving everything to one side. Everything to the, what side is that? The right. So 0 equals x squared plus 18x plus 81 minus 32x minus 48. Okay. I don't like the orange. Let's do blue. Mariana, do you understand?
Yeah, it's a lot.
It's a lot. It's a lot. Okay. So x squared. I know. Then let's see like terms. 18x and minus 32x. What is this? What is 32 minus 18? It's like 14. Is it 14? Jason says yes. So we can blame him if it doesn't work. 14x. Okay, 14x. And then we have 81 minus 48. 33. Is it 33? 81. I think it's 33. Positive. Again, Jason said yeah. So does this? Oh my goodness, these factors. How does it factor? You tell me.
Oh my goodness. It'll be X.
XX, we know this part here, yeah. Then which two numbers
11
multiply?
and 3?
Yeah, it is 11 and 3. I think they're all made so then they would factor, because sometimes if it doesn't factor, you need to use the quadratic formula, but I think all of those here they would factor. Okay. So Mariana says 11 and 3. Okay, now we need to solve it. So set each one to be 0, so we have x equals 11 or x equals 3. But we're not done, because now we need to do what? Check. Let's do pink. So now check. Ay. 1. Okay, well, it's a big mess here. We're going to look. Let's look at this black one. I kind of did here. The black one. I mean the white one. Let's look at the original. Let's plug it in there. See the white? The black equation on the white background. Okay, so check. Plugging in. We're plugging in 1. Okay, so 1. Put 1 here and 1 here. See? Oh, you're so smart. Oh my gosh. Good thing we have you. Oh, good. Okay. 11, that's good. Okay. So, on this side we have 11 minus 2, 9, right? So 3. The other side we have the minus 2. 2 times 11 is 22, and 3 is 5, 25. So square root of 25 is 5. So this checks. I know I did this. So because 3 is on one side, does this equal minus 2 plus 5? It does. 3 equals 3. So this one is checked. So we can circle it. So let's check the 3 now. Now we're going to do 3. 3. So I'm putting 3 here and 3 here. So 3 minus 2 is 1. Square root of 1 is 1. Okay, 1. Let's do the other one. Minus 2 is minus 2. 2 times 3 is 6. Plus 3, 9. So this is 3. The whole thing is 3. So I have this one equal minus 2 plus 3. Yes. Hey, this is one has 2 solutions. Look at that. They both check. So this is the problem when I had some students who were like desperate. I just could not do this and I give up. But you are so much smarter and stronger and energetic, and so you can do this. Right, Mariana? This is all she can say. Okay. So let's see. She's like exhausted, but this is like, I feel exactly the same way when I'm driving on the highway. Some, not so much here, but some other places, and you start exiting, and then you exit, and you turn, and you're turning more, and you're turning even more. It's like, when is this going to end? You're kind of getting frustrated with this thing turning all over the place. And I'm like, I want to quit in the middle. I was like, I don't want to turn anymore. But you have to. You see, so this is like this. You go and go and go and go. So see how nice they did the check, like step by step. You can do it this way. To right. Oh no. What's that? And this is all we do. Okay, the end. So next time we're going to do
Decimals?
no 10.8. After that, next week we do review chapter 10 and test chapter 10. So the goal, objective, chapter 10, all those 70 are due on Sunday. This Sunday. So get to business, Mariana. And you can do this, I know. Oh, we need to stop the recording. Okay, stop.